Okay, so you can probably tell by the giddiness in my voice, this is my absolute favorite thing to do. Verifying trig identities. This is going to be so much fun. That is not sarcasm. This is really a lot of fun. Here we go. So, there's going to be some rules. Remember how I told you simplifying trig identities, or simplifying trig expressions, I should say, it was like a puzzle, but no one gave you the box, right? So you just had this Ziploc bag full of puzzle pieces. What kind of monster would do that, right? Well, this is the puzzle, but now you have the box. So it's just like doing a puzzle. It's so much fun. All right, so we've got a couple rules though. We're going to choose one side of the identity that we're given. Usually the left side, but it's really up to you. The main rule is you do not touch the other side. Okay. Now, a big hint actually is usually you want to pick what looks like the more complex side. Now, sometimes that can be a little ambiguous. Technically, it doesn't matter which side you choose, but if one side is definitely much simpler looking than the other, if you try to work with the simpler side, it's going to be more difficult usually. So choose the more complex side. Again, usually that just happens to be the left side, but you do not touch the other side. And going to my puzzle analogy, touching the other side would be like cutting up the box to make the pieces. So you don't want to do that, right? You just know what the box looks like. Okay, strategies. First one, of course, have fun, because this is going to be fun. Second strategy, use your identity. So just like with simplifying, we're going to use our identities to match one side to show the other side. But the nice thing about having the box, that was my air quotes again, is we know what that other side is supposed to look like. So that gives us a much bigger hint on which identities we should try to be using. Then we're going to use some of our algebra techniques, so like factoring, distributing, combining fractions, adding or subtracting fractions, splitting up fractions. So if we recognize, oh wait, I started with a single term, but the answer has two terms, then maybe I need to split up a fraction. As I mentioned before, note which trig functions are in the final expression, because that's going to help us with deciding which identities we're going to use. Maybe multiply the top and the bottom by a conjugate if you need to. Sometimes that is a thing that can create the difference of squares, which sometimes leads to our Pythagorean identities. And then if all else fails, same as before, you can change everything to sines and cosines. That's not always going to be the best strategy, but it will usually get you in the right direction if you are completely lost. So that was a lot of me talking. I'm really excited. Let's go ahead and start. Okay, so secant of y times cosine of y equals 1. Now, again, we're only working with one side. So when I look at this, the left-hand side looks more complex than the right-hand side. So I'm going to choose to work with the left-hand side, and I am going to verify or show that that does actually equal 1. Now we're starting out simple, so hopefully this is pretty simple. I know that secant and cosine are reciprocals of each other, so I'm going to change one of them, not both of them, but just change one of them into the reciprocal. It doesn't matter which one I change, so I'm going to make this 1 over cosine of y. This is still cosine of y. Now another thing, make sure that as we're working, I'm working vertically. I'm just going to continue to write the equal sign each time. I don't have to keep writing 1, but I'm only working on the left-hand side, and I'm only working vertically. Reduce, and then I get 1 equals 1. Verified. Okay. A couple other things to talk about. And again, this will be more important when you get to an actual class where grades are involved. So I know what the answer is going to be. This should be my answer for this problem. Even if I didn't know how to do the problem, I know what the answer is. So keep in mind, if there was a grade involved here, the grade is strictly based on your work, not your answer, because you start with the answer. You know what it is. Similar to if you've taken a geometry class and you've done proofs, perhaps. You know what you're trying to prove, so you know what the last statement is. This is actually a form of proof. The only difference is I don't have to write if-then statements verifying or, justifying each step that I do, as long as I'm showing my work vertically and it can be followed. Let's do another one. So I've got sine of b over tangent of b equals cosine of b. Okay, which side looks a little more complex? Well, the left side. On the right-hand side, so I'm going to talk out loud. Well, weird if I talked with an inner monologue on a video. But the right-hand side has cosine. The left-hand side has sine and tangent. So let's change tangent into sine over cosine so that I'm introducing a cosine. And so again, my thought process is, what am I trying to get to? How do I create that? So I'm going to leave the top sign as it is. So I'm going to make this sine of b over sine of b over cosine of b. Now I have a fraction divided by a fraction, so I'm going to multiply by the reciprocal of the denominator. These cancel here, so I'm going to just write out an extra step, even though I know what my answer is at this point. So I have cosine of b over sine of b times sine of b. So now these cancel, and I'm left with cosine of b equals cosine of b. Boom. Let's do another. Okay, getting a little more complicated. So which side looks more complicated? The left side. I've got cosine of x plus sine of x times tangent of x equals secant of x. I don't know what to do, right? I don't have a secant, so how can I introduce a secant? Well, secant relates to cosine. How does it relate to cosine? It's a reciprocal of cosine. So, let's change this tangent into sine over cosine. Okay, let's just see what happens with that. So I'm going to change this. So I'm going to leave this as cosine of x plus sine of x. Sorry, computer's being a little glitchy. Times sine of x over cosine of x. Ooh, that's nice. Hold it. I got a cosine in the bottom. That's the same as secant, right? Okay. So let's combine these. So I'm going to do cosine of x plus sine squared of x over cosine of x. Okay, so now let's think a little bit more. All right, I know I have this cosine in the denominator that I can make a secant. That's good. But also notice that what I'm trying to get to is a single term. Right now I have two terms separated by addition. If I get a common denominator, I can make this into a single term though. So let's do that. So I'm going to multiply the top and the bottom of this by cosine, so I get a common denominator. So now I have cosine squared of x plus sine squared of x all over cosine of x. Hold on a sec. Wait. You see what this is? The numerator. Oh my god. Cosine squared of x plus sine squared of x. That's my Pythagorean identity. That's beautiful. This is perfect. So that is 1, right? This whole thing right here, that's just 1. So I get 1 over cosine of x, which, oh my god, isn't it? It's amazing. Secant of x equals secant of x. That was great. That was a fun one. Now we're getting into good stuff. Okay, so what do you think I'm going to have you do? Well, maybe not this one. All right, so let's do one more together. Okay, so how do I start this? Well, there's a few ways to go about this. We're going to work with the left-hand side, but I want to really pay attention to the fact that I want secant to the fifth of x and tangent to the third of x. Okay, so what are we going to do? Well, I have secants and tangents on the left-hand side. So here's something that comes with practice, but I'm going to tell you now. I don't need to use any trig identities probably on this problem. This is probably algebra. Maybe something happens with the trig identities, but most of what's going to happen is going to be algebra. And I know that because the trig functions on the left are the same as the trig functions on the right. Now, again, I could be wrong. Maybe a little bit of trig happens, but most of what's going to happen probably is algebra. So notice that these parentheses here, this parenthesis, and this parenthesis here, are really not necessary and actually just make the problem look more confusing than it needs to be. So this problem right here, this is all just multiplication. This is actually secant to the seventh of x times tangent of x. And then this is actually secant to the fifth of x times, oops, I don't need that parenthesis, times tangent of x. So here's the algebra. Let's factor. Let's take out a greatest common factor. What's the greatest common factor? Secant to the fifth times tangent. They both have at least a secant to the fifth of x, and they both have a tangent. So I'm going to factor out secant to the fifth of x, tangent of x, and then the first term here, this becomes secant squared of x. This becomes 1. So now I know I'm really close to my answer, right? Because I have my secant to the fifth, so that part's done. This tangent of x needs to become a tangent cubed. But hold up, wait a minute, secant squared of x minus 1, that's my Pythagorean identity. This is tangent squared of x. So now I just have multiplication, secant to the fifth of x, tangent of x times tangent squared of x. What does that become? Tangent cubed. So we get our answer. There we go. Okay, next one. Now I am going to have you try this one on your own. So pause the video, try to verify, unpause when you're ready to check. Okay, so let's look at this one. What can we do here? Well, again, now we're starting to get into territory of there's a lot of things we can do. Some are just going to be more efficient than others, but as long as we don't break any rules of algebra or any rules of trigonometry, it's really up to us. So what I did, my thought process was, okay, the left-hand side is definitely more complicated. I'm trying to get down to just a single term that is secant of beta. So let's just turn everything we can into secants right now. So I said, okay, well, cosine of beta is 1 over secant of beta. So my first step was going from the black here to the green. So I left the numerator the same, and I changed the denominator to 1 minus 1 over secant of beta. Now my thought process was, I don't like having division of fractions. I don't like having this fraction within the denominator of this whole fraction. So let's multiply the numerator and denominator by secant of beta so that I can get rid of this. Because I want to get rid of the denominator part, I'm going to distribute the secant in the denominator, and that becomes secant, and then minus 1, because secant of beta over secant of beta is 1. And in the numerator, I didn't want to distribute because I want to keep this secant by itself. Then conveniently, the secant of beta minus 1 over the secant of beta minus 1 cancel, and I get secant of beta equals secant of beta. All right, we're going to be out of time on this video. So let's go ahead to the next video, and we'll do the next problem.